Okay, nice short synoptic video on radians, and again, it'll be very, very short. First of all, what is a radian? A radian is a measure of angle, like degrees and gradients. Degrees are the ones you're more familiar with. What's special about a radian? One radian would describe an arc length. So if you imagine you have a sector, a if that sector has a angle of 1 radian, that means the arc length of that sector will equal the length of the radius. So it's very, very implicitly kind of bound up with the definition of what a circle is. You don't really need to worry too much about the definition other than you know it's got something to do with circles. Pi radians is 180, 2 pi is 360, and then you've got this whole bunch of fractions of it which work in much the same way. What's the main use of it? Obviously, the one that I told you the most of was the differential of sine being cos. That only works for radians. It doesn't work for degrees. So that's an incredibly useful thing, that knowing that sine differentiates to cos and cos differentiates to minus sine, etc. Another three quite useful things are the fact that for a sector, an arc length, instead of that horrible formula of theta over 360, just theta r. The area of a sector would be theta over 2r squared. And finally, the area of a segment would be theta over 2r squared minus theta over 2r squared sine theta. Only works in radians. The graphs of sine, cos, and tan are unchanged by all this. The only thing is, instead of writing 0, 90, 180, 270, 360, you will be writing 0, pi over 2, etc., and all the rest of it. That's really all it is for the basics of radians. There's questions you can do with them, of course, but those are the basic concepts. The most important thing you need to remember is how to convert back and forth between them and these three formulae. As for the differentiation stuff, the questions generally take care of that. They won't ask you how to differentiate sine in terms of degrees or anything like that. And that's pretty much all you've got. Radian's done.